Congratulations, you have made it to the last section of this chapter. And since this is the last chapter of this class, this is the last new thing you're going to learn this semester for this 3-hour class. I knew you would like that one. So, this is the last lesson. We'll hop right into it, the parabola. I know we remember that the shape of parabola is the shape that a quadratic equation makes. And so we associate parabolas with quadratics. That's great. Keep that association. But really, parabolas come from conic sections. And a parabola, although it's the shape that a quadratic makes, is defined to be the set of all points in a plane that are equidistant from a fixed line and a fixed point. So if you notice, if any of you have folded your parabola yet, when you drew the parabola on the patty paper, it was just a line and a dot. And you put the line on the dot. And as you folded it, a parabola showed up. The dot that we've been working with has been called the focus. Every one of these shapes has a focus. The other ones have two, so they were foci. But this has one focus. That is the fixed point inside the parabola that the parabola is equidistant to. The line is called the directrix. It always is perpendicular to the axis of symmetry, meaning it's completely outside of the parabola. Now we know that quadratics will either make happy parabolas or sad parabolas, but that's because we are writing them as functions. We can also write them as just relations where they open side to side, meaning they don't pass the vertical line test, but they are still the shape that we're going to be plotting today. They still have a focus and they still have a directrix. The focus and the directrix are equidistant from the parabola all along the parabola. So this point is equidistant from the focus to the directrix. The distance that they are apart from each other, that is the focal length. And if you notice, all of our shapes so far have had a focal length. The length for those from the center to the focus. Today it's going to be from not the center anymore, but from the vertex. However, I'm still using the same color scheme because the vertex is still H and K. So even though for every other shape, the orange has been used for the center, we're changing the vocabulary word here to the vertex. However, it's still H and K, so we still use it the same way. It's always the starting point of things when we're graphing and we're writing the equations. Now, clearly I need to be annotating this graph as well. So we have our center, not the center. Hello, I just said that. It's the vertex. We have the foci, focus. Hello, there's only one. We have the focus inside the parabola and equidistant. So about the same distance that the focus is from the vertex, that's called the focal length, you want to go the same distance outside of the parabola itself to draw in our directrix. Now, the directrix should be a straight line. Please forgive the fact that I cannot draw a straight line to save my life. This is the directrix. So the vertex is directly in between the focus and the directrix. The same way our other shapes, the center was directly in between the foci and the vertices. So those ideas are the same. The other things that we have in a parabola is an axis of symmetry. We know this from when we studied quadratics. The axis of symmetry is the line that divides the parabola into two equal pieces. It goes through the vertex. We won't really use the axis of symmetry all that much for graphing by hand because there's another something that's useful. When you're graphing a quadratic, the axis of symmetry is very useful because then you can just reflect the points across that axis of symmetry. But when we talk about this in terms of conics, we also have a new vocabulary word called the latus rectum, which is the line segment that passes through the focus, is parallel to the directrix, and has its endpoints on the parabola itself. What we can think of this as is the width of the parabola. The longer the LR, the wider the parabola. The shorter the LR, the narrower the parabola. So it gives me two more points that I can connect the dots with. And so once I find the vertex orange and the LR points green, we can connect the dots for these parabolas. So this is actually way simpler than the other shapes. Now, like I said earlier, These formulas are a lot simpler, but they follow the same idea where we need to find a missing value. In the ellipse and the hyperbola, that was A, B, and C. In the parabola, all we need to find is that focal length P. Because in both versions of a parabola, the P helps us write the equation. But it's also very easy to find. It is the focal length. So it is the distance from the vertex to the focus, or the vertex to the directrix. If we're adding in all of our color coding here, we have our focus inside the parabola. We have our vertex acting as the center of the parabola. We have the directrix on the outside of the parabola, equidistant from the focus to the vertex and the vertex to the directrix. Notice that one of them is a Hoy line, horizontal, so y equals. And the other one is a Vux line, vertical, which means its equation is x equals. The last thing we're going to draw on here, because it's the last thing we really want, is the LR. The LR goes through the focus and hits the parabola, equidistant on each side. So if the LR is 16 units long, that means there would be 8 on either side of the focus. Clearly, we have formulas here for the focus and the directrix. Notice that unlike the ellipse and the hyperbola, are you adding and subtracting the focal length from this coordinate point? No, what are you doing both times? Just adding. And for the directrix, are you adding and subtracting the focal length? No, what are you doing? Just subtracting. So you don't have to write a whole bunch of coordinate points for these. It's a lot simpler. The last thing I want to bring to your attention, and maybe if you don't notice that this is highlighted green, this is one of them. The LR has a formula that it is square absolute value of 4p. That's how long it is. P is your focal length. So again, we just need to find the vertex and the focal length P, and we're good to go. Now, there are 4 options for the way this graph might look. For an absolutely normal, looks like most quadratics you've seen in your life, the p-value is going to be positive and the x is going to be squared. Notice that for a parabola that opens up and down, x is the squared term. Do we see this? So if you have a positive p here, it's like you have a happy parabola from when we studied quadratics. If this was negative, you'd have a sad parabola. What would it look like? A little down. If, on the other hand, the y is the squared term, do y'all notice this on the second side? If the y is squared, that's weird. That's different. That's not normal, which means these parabolas are going to open side to side. It's either going to be a C or a backward C. If p is positive, we're going to open to the right, so it's a C. And if the p is negative, that's a sad parabola moment, but we're side to side, so that's a backward C. So we have to make a bunch of choices about what the shape might look like, but it all comes from the formula. We look for which of the letters is squared, x or y. We find the vertex, we find the focal length, we plug in the formulas, we graph. Sound good? Let's see what this might look like. Did everybody color code enough? Great, let's see what it looks like. Just like with our other notes, we're going to graph 3 of these guys. First things first, what letter is squared in this parabola? So is this going to open up and down or side to side? Side to side. Now which side? Is the number next to the non-squared term positive or negative? Positive. So a positive side to side is going to be a C. If it was negative, that would be a backward C. We look for, yes I can, to explain that one more time. Which of the letters is squared? Y. So this is going to be one of the side to sides. We look at this number next to the non-squared term, next to x. If it's positive, that's C. If it's negative, that's backward C. Yes? Okay, what is the vertex of this parabola? The vertex are the numbers that have been added and subtracted to x and y, the h and k, just like everything else. What's h and k here? Yeah, 0, 0. So our vertex is at 0, 0. A nice boring example for you to start us off. We now need to find our focal length. Instead of having to find A, B's, and C's, all we have to find is P. But we know from the formula, and you can look back at the formula, that the number next to X in the formula is 4P. What's the number next to X here? 12. So if I say 4P is in the same spot as 12, that's like saying 4P is equal to 12. And if 4P is equal to 12, what's P? 3. So my focal length is 3. That's the only number I need to now find every other piece of information about this parabola. The first thing we want to find is the focus. The focus is always found by starting with the vertex and only adding the focal length P to one of those coordinate points. Now you can look at the formula chart for this, but remember we said this should open side to side. So if I'm looking at the vertex up here, should the focus be up and down or side to side? Which means, am I adding the focal length to the Y or to the X? We're actually adding it to the X. Remember, we're trying to go side to side to put that focus inside the C, which means we have to move to the side. So my focus is going to be at the coordinate point 3, 0. That's 3 units away from the vertex because my focal length is 3. After we find the focus, we do need the equation of the directrix. That is an entire equation, so it should be x equals or y equals. For this particular shape, yes, you can refer to the formula chart. But if you think again, the directrix has to be outside, not touching the U, the C, LOL. Would it be side to side or would it be up and down? Up and down. That is a Vux line, and Vux lines always start with x equals. This is going to be x equals to k minus p. I'm sorry, h minus p. I said the wrong letter. Which means my directrix is at the line x equal to -3. That is a Vux line 3 units behind or outside of the C value. C value, hello, the C shape. We only need one more thing to be able to graph this, and that thing that we need is the LR. The formula for the LR, let me do that in the actual correct color, hello. The LR is found with the formula absolute value of 4 times P. But what was our P value here? 3. What's 4 times 3? 12. And what's the absolute value of 12? 12. So my LR is 12. And what that tells me is that if we split it in half, we're going to have 6 units on one side of the focus and 6 units on the other side of the focus before we put our green dots. And since this is a C, you're going to go 6 units above the focus and 6 units below the focus. Now this won't make sense till you see me graph this, and you'll see what I mean by 6 above and 6 below. We're already ready to go. Yes?
So how did you eventually dictate that the LR would have the, what are those called?
Absolute value?
Did the absolute value and not the focus point? Like why did that 4P not get the absolute?
That's a great question. The LR is a distance. Can distance ever be negative? No. So since LR is a width or a distance, how wide it is, it's always going to be a positive number. The focus and the directrix might go a negative direction. They need direction. LR is just a distance. That's a great question. So if we go start to try to graph this, we do start like always with our orange point. It's no longer a center, it's a vertex. We also will plot our focus. We said our focus should be 3, 0. We said our directrix should be x equal to -3. So we draw a dashed line as our directrix. Notice that just like last time when we were always checking to make sure our foci had the center in the center of them, this time the focus and the directrix should have the vertex right in the middle. Is our vertex right in the middle of these two things? Okay, we're good. We put them in the right spot. The only thing we need now is the LR. The LR has to go through the focus. So if I go 6 units above the focus and 6 units below the focus before I put my dots, isn't that LR, that green line, 12 units long? 6 above, 6 below, boom. We have now the width of our parabola. This guy's really wide because we connect the vertex and the coordinate points found by the LR together. Ta-da! We're already done. That's significantly less work than the hyperbola. Nice. Questions, comments, concerns? I need another one. All right, fine, here we go. So here's the second equation. What do you notice about the second equation? The x is squared. That's normal, right? For an x to be squared. That's what we're used to in quadratics. So this is either going to be a happy or a sad parabola, classic style from quadratics. Will this one be happy or sad? Sad because of the -8. Very good. So we know that at the end of this, we should have some sort of sad parabola because the x is squared and the number is negative. What is the center of this parabola? Not the center. Hello. What is the vertex? Yeah, it's still 0, 0. There's no number added and subtracted to x or y, so h and k are still both 0. How do we find the focal length P? Very good. 4P equaled -8. So quick math tells me, what is P equal to? -2. Okay, cool. Now we're ready to find all the things because all we need is P. We find the focus. The focus we always, again, set up by putting the, not center, vertex on our paper. But this time, since we have a sad parabola, will my focus be to the right and left of the vertex or above below the vertex? So are we adding the number -2 to the x coordinate or the y coordinate? The y coordinate. Now I'm going to write plus -2 on purpose so that when you look back at your notes later, it is always plus. You just might be adding a negative number. Clearly that's just subtraction, but it's always adding whatever that number is. So that means our focus will be at the coordinate point 0, -2. Our directrix is at the line y equal to k minus p. It's y equals, because if we have a sad parabola, we can't touch it, so we need a horizontal line above it. Horizontal lines are y, so we grab the y coordinate 0 and subtract -2. Again, minus a minus looks gross, but I'm putting it there so you see that we are always subtracting. What is minus a minus? Plus, so my directrix is at y equal to 2. We need the LR. The formula for the lattice rectum is the square root of 4 times P. You guys told me it was -2. 4 times -2 is -8. And what is the absolute value of -8? 8. Which means if we split this in half, we'd have 4 on one side and 4 on the other side of the vertex. Now, is this going to be above, below this time? No, it's going to be side to side because our lattice rectum tells us the width. So we're going to do 4 on the right and 4 on the left of the focus. We start with the center. We graph our focus, which we said was at 0, -2. We graph our directrix, which we said was at the flat line y equal to 2. We graph our LR, which is a distance at the level of the focus. 4 units on the right, 4 units on the left to get our green coordinate points. And then we play connect the dots. Now that we've seen 2, questions, comments, concerns? Similar to our notes in the previous lessons here, our third example is not going to have a vertex at the origin. Before we talk about the vertex though, what kind of parabola are we going to have? Happy, sad, or C and negative C? Happy, sad, why?
Because the x is being squared.
Because the x term is squared. Very good. Now specifically, is this going to be a happy or a sad? Happy. Why happy? Because the 8 is positive. Okay, cool. I agree. This time, where is the vertex? 3 and negative 1. Now this is easy because it was x and then y. Remember, it's always h and k. It's always x and y. So if this is a side-to-side parabola and it's not on the origin, don't just pick the first number and the second number. It needs to be h and k, so the x and then the y. The other thing we need from the equation is the value of p. What would 4p be equal to this time? 8. Very good, which means p is just 2. So when we go to do the focus, we start off with the vertex itself. And this time we're going to add the focal length to the y's because the focus should be above the vertex. That's a y direction. So we're going to add the focal length, which is 2, to the y coordinate of the vertex. This means that our focus this time is at 3, 1. 2 units above the vertex for this happy parabola. 2 units above. So we add it to the y's. The directrix will be a y equals equation. The y value in this equation is negative 1. That is what we are going to subtract 2 from. We always subtract the focal length for the directrix. And again, the 1 comes from the fact that the y coordinate of the focus is negative 1. I'm sorry, y coordinate of the vertex is negative 1. Which means that my directrix is going to be at the line y equal to negative 3. That's a Hoy line at negative 3. The LR is found with that same formula. Absolute value of 4 times p. P is 2. 4 times 2 is 8, and the absolute value of 8 is 8. So just again, we will have 4 units to the right and 4 units to the left of this LR. It will probably ask you on questions the length of the LR. That's 8. We just know that I'm dividing this by 2 so that we can graph 4 above or below or 4 right and left. But the LR is 8. So when we go to graph this one, we start with the vertex. This time it's not at the origin. It is at the coordinate point 3, negative 1. We said the focus is at 3, 1. Notice that that is 2 units, my focal length, 2 units above the vertex. My directrix is at y equal to negative 3, 2 units below the vertex. The focus and the directrix have the vertex in the center of them. All we need is the LR. The LR is 8, which means we'll go 4 units on each side. So we go 4 units to the right. I know it's off screen, so sorry. And 4 units to the left to draw our green dots. Green, Miss Figley, not pink. And then we can graph our curve of the parabola. How are we feeling? This is much easier than the hyperbolas, yeah? There's not like invisible boxes and invisible lines happening here.
don't get it.
Can you ask me a question? Like, do you have a...
It's just a general.
Okay, we'll work on it. Thank you for your honesty. Always. Okay, now, just like the last examples, or last sections, we do have 2 more examples to go over on the back side here. One is going to ask you to write the standard form of the equation given some pieces of information. So we'll work backwards like we have in the last classes. This one tells me that the focus is at 5, 0 and that the directrix is at x equal to -5. I personally still need a little sketch to see what's happening here and make sure I'm making the correct choices. So if I was doing this, my focus is at 5, 0 and my directrix is at x equal to -5. We should discover just from this sketch a lot of information. Number 1, is this parabola going to open up and down or side and side? Is it going to be a C or a backward C? A regular C. Okay, cool. That's what I agree with because like it's going to have to do this. That is a horrible parabola. Let me try again. Still not great, but better. The other things we learned, on that train of thought, is this formula going to have x's squared or y squared? Y's are squared. Other things we learned, what's the location of the vertex? 0, 0. Remember, the vertex has to be halfway in between the focus and the directrix. Pretending I drew my line better. What's right in the middle? 0, 0. I'm not an artist, okay. We know that the center, not the center, hello, what's it called in this lesson? The vertex. We know the vertex is at 0, 0. My bad. We also learned the focal length. We learned P. P is the distance from the vertex to the focus and the vertex to the directrix. How far away is the focus from the vertex? 5. And how far away is the directrix? 5. So P is equal to 5. If we know all of this, we know exactly the formula. We will fill in the formula for one that opens side to side, which is y minus k squared equal to 4 times p times x minus h. Where am I getting this from? Great question. The formula chart. It says y minus k squared equal to 4 times p times x minus h. You see it now. Okay, that's what I got it from. But like we can clean this up. Y minus 0 is just y. 4 times 5 is 20. And x minus 0 is just x. Resist the urge to square both terms. In a parabola, only one of the terms is squared. In a hyperbola and an ellipse, both are squared. In a parabola, only one is squared. That's it. All we need is P. These questions on the other ones, we had to find one of the missing terms, A, B, and C, and do a whole bunch of stuff. We don't have to do that here. We just need P. And just like we ended the last lessons, again, we can go from general form to standard form, but like question, how many terms are squared in a parabola? So how many times are we going to have to complete the square? Just once. Sigh of relief, am I right? We just have to complete the square once. But my question for you is, are we completing the squares on the y's or on the x's here? On the y's. Why? Yeah, so I want you to circle this real quick and write yourself a note that we only complete the square on the y's. Because there's no squared x term. So what we're going to do is on our organization step, on the left side of the equation should be all the y terms and a magic box. So that would be y squared plus 2y plus mystery box equals. Everything else goes to the other side, including the x term this time. So if I take that x term, the 12x to the other side, what will it become? Negative 12x. And if I take the negative 23 to the other side, plus 23. And then, of course, don't forget the magic box on that side. We don't have to do 2 mystery boxes, just 1. We're already ready to complete the square here, because did I need to divide by anything in front of the y squared? No. Okay, again, we can handle this. The formula for completing the square is b over 2 squared. 2 over 2 is 1. 1 squared is 1. So the number that goes in the mystery box is 1. That's nice. Let's condense some stuff down. Once we make that perfect square trinomial, it will automatically factor to y plus 1 squared. The plus 1 came from here. And then I need to condense the left side. Now, in the questions before this, you could take everything, throw it in a calculator, and just write the number down. You can't do that here. Because what's on that side? An x term. So we're going to leave the x term alone, and any of the regular numbers we will add together. So that's 23 plus 1, 24. We're super close to being done. We're not quite in standard form because we should have parentheses on both sides. Just only one of those parentheses is squared. So we need to factor something on the right side so that we have x in a set of parentheses. What do both of these terms have in common? Negative 12. So if we factored out the negative 12, meaning I divided both terms by negative 12, the things that I would have left over are 1 single x, and 24 divided by negative 12 is negative 2. Now it's in standard form. We could tell you this, the vertex, which is 2 comma negative 1. We could find the p-value, which would be negative 3, because 4 times negative 3 is negative 12. And we could graph the focus, the directrix, the LR, and all the things we needed.
Yo, that's big.
It's much nicer, right? We can handle it? I agree.